All right. So today, remember, here's what you got going on. You have a test with 3 things on it. You got it? What's the first thing? I already told it to you. Regressions, linear regressions, okay? So, so that you already know, and you have the worksheet for it, right? Today I'm going to teach transformations. All it is one example in section 7, okay? And it's example 5. I'm going to teach you how to do it. You really already know how to do it, but we're going to do it a little bit differently, okay? And then I'm going to give you 6 problems to work. You're going to add those 6 problems onto that regression worksheet and turn that all in next class. It's only going to be about 11 problems. So I'm telling you that because they're all worth almost 10 points. So can you miss a whole bunch of them? No. So, and what I'm calling a problem is, like on the regression worksheet, the very first problem has 2 answers, but that's one problem. Actually, it has 3 answers. One's the graph, one's the equation, and one's the r squared, right? So, but that's one problem, okay? And when I give you these 6 problems, it'll be 6 problems, but each problem will have 3 answers to it, okay? So on the worksheet, the regression worksheet, when I say a problem, it may have more than one answer, but I'm grading it as one problem, okay? So be careful with that. That's due next class. And then next class, I'll teach you the last thing, which will be piecewise functions, and then we'll have our big test, 100-point test, with 3 skills on it, okay? And it will be, Thursday, Wednesday, Thursday of next week, okay? I was like, what? When will it be, y'all? Wednesday, Thursday. Okay, so let me show you what you know about transformations. So this is an absolute value equation. What's it going to look like? It's a V. Very good. Did you know that I had kids on the test and they, I actually graded a test today and a kid drew a parabola.
What an idiot.
I'm like, oh my gosh, please. People, you have a calculator. If you don't remember what it looks like, put it in the calculator. It'll show you what it looks like. Like, that's the craziest thing I've ever heard. Okay? Lots of kids just drew lines. No, just going to draw a line, Miss Davis. Okay. So, put your phone up. All right. So, what does this negative do? What does an absolute value look like when you graph it? A V. Okay, what does this negative do to my V? All right, so instead of opening like this, he's now opening like this, okay? What does this minus 3 do to him?
It's where he is on the x-axis.
Moves him where?
To the right.
To the right 3. Where does this move it?
To up 1.
Up 1. Okay, so if it's with an X, it is an X. It moves left to right, opposite what you think. And Y's do just what you think. This 2 is my slope, so actually from that vertex point at 3, 1, you will go down 2 and to the right 1 and to the left 1. How many points did I ask you to put on your absolute value equations? 3. The vertex, and use the other 2 points to show me your slope. Some people just put 1 point on them. So out of 3 points possible on that problem, they got 1 out of 3 because they didn't put 3 points on there. So rules for transformations. Order is important. These are the 2 things that matter, okay? If you're reflecting something over the x-axis, you're always going to do it first. And if you're reflecting something over the y-axis, you're always going to do it last, okay? So if you have a negative on the front, it's on a y, not an x, okay? It reflects it over the x-axis, and you would do it first. So the first thing we do is we look at this negative and we say, oh, we have an absolute value equation like this, and that negative reflects it over, and now it's opening down. You can't wait until the end to do it. You have to do that at the first. If it's with an X, it is an X, and it moves left or right, opposite what you think. Or you could say opposite of the sign, okay? Like a plus moves to the left and a minus moves to the right. If it's not with an X, then it's a Y, and it moves up or down, just like you think. Or you could say like the sign, a positive moves up and a negative moves down. If you have a negative on the X, this is going to be one of the most difficult skills. You are going to reflect it over the Y-axis, and you will do that last, okay, after you've done all the other transformations. Okay, so I'm going to teach this lesson today. today, and I'm gonna teach it 2 ways, all right? So the first way I'm gonna teach it is very visual. So for those kids that learn visually and everything, then they will like this. But after a while, you'll be like, wow, I don't know, Miss Davis, that's kind of hard to do, and it is. So after a while, we'll figure out the other way to do it, and most of you will choose that way. So here we go. I'm gonna draw a little coordinate plane. All right, and so here's what's gonna happen. They're going to give you a function, all right? And they're not gonna give it to you with an equation or something like that. They're gonna give it to you as a graph. And there will be specific points that will be marked on your graph. Actually, the function that I'm gonna give you is gonna have 5 specific points that are marked. Here's the first one. Here's the second one. Here's the next one. That was wrong. Here's the next one. And the next one. Okay. So this is what our function looks like. Now, what I want to do is I want to teach you how to use your rules for transformations and transform anything, okay? Can I cheat on the calculator with this one? No, because you can't graph that on the calculator. You see what I'm saying? So I'm just testing to see, do you know them? All right, so the first rule is you have to count the number of points that are marked. How many are marked? 5. 1, 2, 3, 4, 5. So we're going to make 5 blanks. 1, 2, 3, 4, 5. The order that you write these points in is important because I'm going to be grading this stuff, okay? And I can't read your mind and you're not going to be with me to tell me what you were doing. So I'm going to say you have to put the points in order from left to right. Does everybody understand that? You have to put the points in order from left to right. We're not going from the bottom to the top. We're going from left to right. It's obviously a function, so you will never run into a problem when you're doing that. Okay? So what is the very first point I'm going to write down?
0, 0.
Yeah, this one right here, 0, 0. What's the second point? 2, 3. Okay? And the next one is 4, negative 2. The next one's just 1 to the right, so that's what? 5, negative 2. And the next one is 1 more to the right, but it's 2 up, so that would be 6, 2. Good. Okay, if you get these points out of order, it's going to mess up everything else down your paper, all right? And I won't know how to grade it, so be careful with that. Okay, so let's do the first one. We're going to do an easy transformation. It's going to look like this. 2 times f of x. Okay? Look, I'm going to do it on the graph, but y'all on your homework, I'm not grading a graph. Some kids they like to do it on a graph, and that's fine, you can. But I'm not grading the graph. You have to be able to write the points down. So draw my blanks, 5 blanks. Now, look at this transformation. Does anything happen to the x? No, we're not doing anything. It's just x. So, who is this 2 multiplied by? F of, which is y. Okay? So, we're not doing anything to the x. What are you doing to the y? Multiplying it by 2. Okay? So, now would this 2 is a y, right? Because he's multiplied by the y's. Would he be a vertical stretch or a vertical compression? Stretch. They do just what you think they would do, okay? If you multiplied my height by 2, that would be a vertical, I would be 2 times as tall, right? So what should happen to my graph is it should be vertically stretched. Okay? He's not gonna move left or right any, he's not gonna move up or down any. He's just gonna be vertically stretched. All right, and the way I do that is to multiply this 2 by every y. Don't mess with the x's, okay? So what's the x value of this point right here? 0. The y value is 2 times 0. What is that? 0. So this point, he doesn't even change. He just stays right there.
It's like the geometry formula,
Yes, it is. This is the same thing as what y'all did in geometry when y'all did dilations and transformations. Y'all call them slides and different things like that. Flips and things, reflections. All right, on this guy, what does this point become? 2, 6. You didn't do anything to the x, and you multiply the y times 2. 3 times 2 is 6. What does this point become? 4, negative 4. Good. Leave the x alone. Negative 2 times this 2 is negative 4. What does this point become? 5, negative 4. Okay, I meant to graph these and I forgot. So this one is 2, 6. All right, so he goes like this. I see y'all. Y'all look good. Y'all look very good.
I got the same pants on.
Oh. Okay.
We did have a kid that was moving in, or they go, no, I voted for the math department, so we
I got the
do.
same one.
You do, you can be part of our group.
He voted for the math
He
department?
goes, I'm voting for math, and I said, well, boo, where else do you?
That's funny. All right, so this one is 4, negative 4. So he goes way down here. This one is 5, negative 4. So he goes across here. What's this guy? 6, 4. And so he goes here and here. Okay, so look at the black graph and the pink graph. Does it look like a vertical stretch? Yes, he's just got twice as tall as he was here.
So you only, if you do that, you only make the line big?
Yes, you're only messing with the y, because look what this says. This says 2 times f of x. Well, f of x is y. Do you
Right.
agree? And remember what it says. It says if it's not inside with an x, then it's a y. So this too.
So what if it's at F and 2x?
Okay, so I'm going to talk about that, but I'm going to tell you we're not going to do anything like that, but these are the difficult ones. But listen to this. Okay, first of all, if it's with an x, it is an x, right? What do x's always do?
Their thing.
The what? The opposite? Yeah, the opposite of what you think they're going to do. Y'all, they always do that. So if that 2 were in there on that x, instead of that being a horizontal stretch, it actually is a horizontal what?
Depression.
Compression. And if you compress something horizontally, what does it appear to do?
Stretch taller.
Yeah, be stretched vertically. Okay? All right, so we're not going to do any of those, but that is a very good question. Okay, so let's do the next one. The next one's going to tell me if you kind of know what's going on. All right? So this one looks like this. Y is equal to negative f of x minus 2 minus 5. Okay? Negative f times x minus 2 minus 5. I'm going to write my points down. Here they are. 1, 2, 3, 4, 5. Okay? So listen to me, guys. Your homework is just like this. Your homework is going to give you one graph, like this black one. It'll look different than the black one, but it'll be like that. And then he's going to ask you to do 6 transformations on it. So you're going to list those 3 points, because on your homework there's only 3 points on their graph. And you're just going to go number 21 and draw your 3 blanks. Number 22, draw your 3 blanks. Okay? All right, so let's do this one physically. So this negative, I'm starting at this point right here. That's this guy. I'm going back to this guy right here. There's my point. This negative reflects it over the x-axis. He's on a y, so he always reflects it over the other axis. Do I do that first or last? First. Yeah, these are the rules that we talked about. See how if you have a negative on the front, on the y, you do it first. If you have a negative on the x, that reflects it over the y-axis, you have to do that last. Okay? All right. So this guy, he reflects this first point over the x-axis. Does that move it anywhere? No. He just stays where he is. Where does this -2 moving? Which way? Right 2. 1, 2. Where does this -5 moving?
Down the bottom.
1, 2, 3, 4, 5. So he's right here. So this first point is now right here. Okay? And what is that point? Well, it's 2 and 1, 2, 3, 4, 5. -5. All right, let's do the second point. The first thing I have to do is reflect it over the x-axis. All right, you need to be paying attention. Reflect it over the x-axis. So if this point is 3 above the x-axis, where's the reflection going to be?
3 down.
3 below the x-axis. So 1, 2, 3. Where does the -2 do to him?
To
The right.
Right 2. 1, 2. What does the -5 do to him?
Down 5.
1, 2, 3, 4, 5.
That's our-
So this point right here is that point right there. This line is now this line. You want to see why? Okay, the line is like this, and then I reflected it, so he went like this, and then I moved him right 2 and down 5. Boom.
Now
Okay?
you can just kind of keep doing your thing. You don't really need to.
Oh, I'd be careful doing that. All right, let's take this guy. Let's do the same thing to him. Let's reflect him over the x-axis. So where's he going to be? If this one's 2 below,
Up
where's the
2.
reflection going to be?
Up.
2 above. So he's right here. What does that do to him?
It makes him go to the right.
1, 2, and then what? Down 5. 1, 2, 3, 4, 5. So now he's right here. Okay, what is that? That is 1, 2, 3, 4, 5, 6, -3. And that's actually my third point. I forgot to write the other one down. 6, -3. Okay, this point right here is 1, 2, 3, 4. And let's see, if this is -5, 6, 7, 8, this is -8. Okay? So now he's going up here like this. Now let's do this point right here. A reflection over the x-axis pulls him 2 above the x-axis instead of 2 below. This moves it right 2, 1, 2, and this moves it down 5. 1, 2, 3, 4, 5.
Can't you just kind of start getting the hang of it, go where it is, and then right 2, down 5, right 2?
That's kind of dangerous, but you're on to something, and we're going to use that in just a second. So that point is obviously 1 to the right of this one, so that's 7, and he's staying on the same level, -3. Okay, now we just got to do this last point. So this last point, reflect over the x-axis. So he's 2 above, now he's going to go 2 below. Move him right 2, 1, 2, down 5, 1, 2, 3, 4, 5, and he actually, it's right there. So that point is 8. There's -3, -4, -5, -6, -7. Okay, so visually, look what happened. This reflected it over the x-axis. So the point, instead of being on the top, is now on the bottom. The flat, instead of being on the bottom, is now on the top. That is taking that thing and reflecting it like this. Okay? This -2 took that black and pushed it to the right 2, and then pushed it down 5, and there it is. Okay? Here's my question. Is there a mathematical way to get these points?
Yes.
So, I need you to tell me how to do it, because can you plug in your x and your y? Well, I don't know. Let's try it. Okay? So, let's try this point. 0.
I'm just gonna get you just
X minus two, is this minus two?
No.
No, it's a positive two, okay? So that didn't work.
You just need to do like what that's done. Go to the right, so put plus and 2 on your X.
Okay, so here's what Caden says. Caden said we need to actually mathematically do what we're physically doing. This, if it's with an X, it's doing the opposite. Do you agree? So if this says a minus 2, what do I want to do?
Add 2.
Add 2. So let's see if it works. What's 0 plus 2?
2.
What's 2 plus 2?
4.
What's 4 plus 2?
6.
What's 5 plus 2? What's 6 plus 2?
8.
Boom. Okay? So let's go and write. Now y'all listen. I'm writing this down because if I go back and use my notes and I have nothing written down, I have nothing to go by. Okay? So I'm going to go back and write all this. Remember, we always go back to the original function. That's the black one. So 0 plus 2. 2 plus 2. 4 plus 2. 5 plus 2. And 6 plus 2. All right. Now you got to figure out how to get the y's.
You need to go down, so you minus 5.
All right. 0 minus 5, negative 5. 2 minus 5. 3 minus 5, sorry. Negative 2. That didn't work.
What?
I'm not telling you, so we'll sit here as long as it takes you to figure it out.
That's how you got to it. Oh, you're reflecting. So
Oh.
multiply by negative, then minus 5. Right?
That's exactly right. Okay? And do I multiply by the negative first or last?
First.
First. Okay? So here's what Caden says. Let's see if it works. I'm going to kind of skip over the 0, 0 because 0, 0 sometimes does some funky stuff. And sometimes it'll look like it's working, but it won't be. Okay? So, what is 3 times negative 1? Is negative 3 minus 5 negative 8? Okay, that's maybe. What's negative 1 times negative 2? 2 minus 5?
Yeah.
Negative 3.
It works.
What's negative 2 times negative 1?
2.
And 2 minus 5? Negative 3.
Alright, yeah.
Negative 1 times 2 is negative 2, and negative 2 minus 5 is negative 7. Okay, so remember that whatever is out front, it has to be multiplied by the y, and it has to be multiplied first. Okay, so how do we get these numbers? Well, you go negative 1 times 0, and then you subtract 5. Y's do exactly what you think they're going to do. So if it says minus 5, you'll minus 5. If it says plus 1, you'll plus 1. X's do the opposite. So whatever they tell you to do in the function, you do the opposite mathematically. Okay? So negative 1 times 0 is 0. 0 minus 5 is negative 5. This guy right here. Negative 1 times this y value. Negative 1 times 3, and then minus 5. Negative 3 and negative 5, negative 8. This y value. Negative 1 times 2 minus 5. That's negative 2 minus 5. Oh, it's a negative 2. I was like going, whoa, that didn't work. Negative 1 times negative 2 is a positive 2, and then 2 minus 5 is negative 3.
Same for the next
Okay, same thing for the next one. Negative 1 times negative 2, you might want to put that in parentheses, and then minus 5. That's a positive 2, and 2 minus 5 is negative 3. The
What's this
last
called?
one, negative 1 times 2 minus 5, that's a negative 2 and a negative 5, and that is a negative 7. All right,
What's
so
this called?
everybody okay so far?
Like in
Alright.
math language, if you were saying I'm doing this, what would you call it?
Transformations. You're doing transformations algebraically. This is algebraically, the other is visually. Some kids learn visually, but what they learn too is that after a while, that gets
That's wrong.
really old and it gets hard to do. And like for me, these lines kind of move when I'm looking at them, so it makes it hard for me to do it. I'd much rather do it algebraically. But I don't care how you do it, because I'm not looking at a graph. I'm just grading your points. Okay? All right, so here's your next one. I'm going to let you do this one all by yourself. All right? Y is equal to 2 times f of x plus 3 minus 1. You do them, fill them in, not out loud.
I can do it. How many points?
There's 5.
Excuse me. Sorry.
Alright, I'm gonna do the second point. I'm just gonna do the second point to make sure you're on the right track. And that way, if you're not on the right track, then you can get on the right track. Okay? So, and I'm gonna tell you this too. If I were doing these points, I would do all my X's at one time and do all my Y's at one time. I wouldn't do each point separately. Because once you start doing those X's, then it's just really easy. Okay, so like if I do this guy, I'm gonna do the X's first. If it says plus 3, what do I do? Subtract 3. So 2 minus 3. What is 2 minus 3? Negative 1. Okay? Now let's do the Y's. Multiply by the first number and do this. So 2 times, there's my Y value, 3 minus 1. What's 2 times 3?
6.
What is 6 minus 1?
5.
So that should be your second point.
This stuff's light work.
Light work like you, it's easy?
Like, yeah. It's
Okay.
really easy.
Good, because we're only gonna do one more, and then I'm gonna show you how we use it, and then I will give you your homework.
I can take that homework right now.
Okay.
I'm just kidding, probably not.
All right, you ready? Okay, so watch. I'm gonna do all the X's first, and watch how much easier it is than when you go from one point to another point to another point. Okay, so the X's, all I have to do is go they said plus 3, so I'll minus 3. So I'm gonna take this X, and I'm gonna go 0 minus 3. What is 0 minus 3?
-3.
negative 3. Okay, on this one right here, I'll go 4 minus 3. What's 4 minus 3?
And
This one, 5 minus 3. What's 5 minus 3?
Joe.
And this one, 6 minus 3. What's 6 minus 3?
Tress.
Very good. Okay? So, kind of like you get in a pattern so you keep going. Now let's do the y's. The y's multiply by this front number. If it doesn't have a front number, then you're really multiplying by 1, but you don't do anything, right? Okay, and then you go, so you go 2 times the number and then minus 1. 2 times the number minus 1. So here's my y value right there. So I'm going to go 2 times 0 minus 1. What's 2 times 0?
Not it.
0.
And 0 minus 1? All right, we already did that one, so let's do this one. I'm on the third one. So I'm going to go 2 times negative 2 and then minus 1. Negative 4 minus 1 is, yep, negative 5. And here I'm going to do this y, so I'm going to go 2 times negative 2 minus 1. I go ahead and do this one because it's a check for this guy, okay? I'm kind of knowing he's supposed to be the same. So 2 times negative 2 is negative 4, and negative 4 minus 1 is negative 5. Yep, that makes him right beside this guy. Over here, 2 times 2 minus 1, and 4 minus 1 is 3. All right, anybody got a question? No? Okay, so I want to do one more. This one's going to be difficult, okay? This one's going to be difficult, so it looks like this. We still want to see those points. Y is equal to f of negative x plus 1 minus 2.
Is that a negative F or is it?
Nope, it's just an f.
Oh,
Do
crap.
you want me to do one with you?
No, we can get it.
Nope? Okay.
That really sucks to have that negative in front of there.
Yes, it does. That's gonna make it, that's the one you need to be really careful about. You shouldn't miss your y, but the x's, some of you are gonna miss your x's.
X looks over Y.
Yes. When?
Always.
When do you do this?
When that's right there.
When do you do this?
What?
Last.
Yes, you do it last. You do it last. That's the last thing. Let me show you what I'm talking about. Let's do this second point, okay?
I guess you can help us.
See if you got it right. All right? The y
I
is
can do it,
easy,
yeah.
right? So let's start with the y. So the y is 3 minus 2. What is 3 minus 2? 1?
Or 1 by
1, right? Okay, now the x's, let's do the x's. So, what is this gonna do?
That's gonna add.
No, it's not.
It's gonna subtract.
It's gonna subtract 1. You said it always does the opposite, so it's gonna subtract 1.
I'm just gonna look
So
up
I'm
and
gonna
see
go
what
2 minus 1, and then what am I gonna do to it?
Multiply by negative.
Yeah,
Right
you're
there.
gonna multiply by negative 1 or take the opposite of it, whatever you wanna say. What is 2 minus 1?
Alright, I can handle this now.
1, and the opposite of 1 is negative 1. Okay, if you did it the other way, if you said negative 2 minus 1, you'd get negative 3, and that would be wrong.
Wait, negative, huh? Threw me off.
You gotta add or, it's like you gotta go backwards, okay? You gotta add or subtract first, and then multiply by the number in the front.
That 2 minus 1, you said, right? I thought it would be plus 2.
Out here? No, look what your rules say. Your rules say, if it's not with an X, it's a Y, and it moves up or down like you think or like the sign.
Okay,
So Y's do exactly what you think, so if they subtract 2, you subtract 2, if they subtract 1, you subtract 1, if they add 5 or whatever, you add 5.
you didn't write -2 though.
Yeah, -2, -2, -2, -2, -2. That's the Y's. I just did all the Y's. Now I'm
That's
gonna do
your
the,
paren-
do what? Now I'm gonna do the X's. So I'm gonna take this X value and I'm gonna do the
No.
opposite of this.
Did you
So-
write the second one correctly? Like the
3 minus 2,
parentheses and all?
this one,
Yeah,
yeah?
that's what I was asking. That's a +2, right?
Oh, this one, yes. 2 minus 1
Yeah.
is 1, and the opposite of it is a negative 1.
Okay, I thought you were saying that 2 is supposed to be
No,
negative.
I'm sorry, I thought you were talking about this guy right here, this -2 right here. Okay, so now I'm gonna do the X's. So I'm gonna subtract 1, and then I'm gonna change the sign, okay? So here's my X. So I got 0 minus 1, and then after I do that, that's why you have to put it in parentheses, I want to change the sign. What is 0 minus 1? And the opposite of -1? Very good, okay?
4 minus
On this one right here, I got 4 minus 1, and after I do that, I want to change the sign. 4 minus 1 is 3, and the opposite of 3 is -3. Okay? This one right here, he's a 5. 5 minus 1, and after I do that, I want to change the sign. So 5 minus 1 is 4, and the opposite is -4. This guy, 6 minus 1, and after I do that, I want to change the sign. 6 minus 1 is 5, and the opposite is -5. Okay, so is this hard? No, but here's what's gonna happen. You either know how to do it or you don't know how to do it. That's the problem, okay? And so if you don't know how to do it, you're not gonna get the problems right on the test. I mean, they're not difficult, okay? But some kids are like, oh, I did that in class, I know how to do it. And then they don't ever practice it again before their 100-point test, and their brains don't remember. Or maybe they did it and had it, but they didn't write any of this stuff down, so then when they go back to study it, they don't know what to study or how to do it because they didn't write any notes down. Okay, so here's the next thing I wanna do. One more thing.
If there's like a number before the X, like if that was
You
like
would
2X.
multiply by that number at the end,
Okay.
okay? You would multiply by that number at the end. All right, so, here we go. I wanna show you what these rules look like on graphs, okay? On graphs that you know about. So this is the square root function, all right? Does anybody remember what the square root function looks like?
Was it the
Nope, that's a square, that's a quadratic.
what was the
29.
Put your phone away.
what was
What's 132
Oh.
times 2?
square root?
164?
It is the is it the one that I remember? Sorry, I remember I read it.
Okay, so it's the one that looks like the top half of a
Yeah.
sideways parabola.
Yeah.
Okay, if you forget, you can always do this. What's the square root of 0?
0.
What's the square root of 1? And 1, 2, 3, 4, the square root of 4 is 2. So here is your function right here. Okay, the top half of a sideways parabola. Now, what if I take that function and I do this to it? Y is equal to 2 times the square root of x minus 3 plus 1. Now we're going to use our transformations, okay? So, tell me what this 2 does to this graph. Is it a vertical or horizontal?
Vertical.
Vertical, because he's not inside, y'all, he would have to be in that square root sign with the x to be affecting the x and be horizontal something, all right? So he's a vertical. Is he a vertical stretch or compression? Stretch. If you multiplied your height by 2, guess what? You'd be twice as tall. That's a stretch, right? So now that's gonna take this graph and it's gonna stretch it up so that he's taller, okay? So I'm gonna take this point right here. What is this -3 do to this point?
Where? Go to the left.
Over.
I mean, all right.
To the right 3. 1,
That's
2, 3.
Oh.
Okay, what does the +1 do?
Alright, go up.
Goes up 1. Now that point is right here, okay? Now listen to me. Is this a line?
No.
Is this graph a line? There's nothing straight about this graph. Does everybody agree with that? He's a curve, okay? Is he ever straight?
No.
No, he is not straight. You can't be a curve and a line at the same time. You're either a curve or you're a line. All right, so I can't really call this a slope, because if it were a slope, then it's a constant rate of change. So it would go up 2 and over 1, up 2 and over 1, up 2 and over 1, and you would make a line. Do you agree?
I agree.
But I can cheat and do it one time.
Oh.
If you do it more than one time, you're making a line and your graph will be wrong. But I can do it one time. Look at this guy. What number's out here?
11.
So what is it?
1.
1. Look at this. Up 1 and over 1.
Up.
So what can I do from this point?
Up to.
Yes, you can go up 2 and over 1. And there is my graph. Now, you see how he stretched him? Instead of going up 1 and over 1, he went up 2 and over 1. So he's a vertical stretch. All right? So what if I took this equation and I stuck a negative in front of it?
That really messed me up just now.
It's not going to anymore because you know how to do that. So first of all, who is this negative on, an X or a Y?
Wow.
A Y. So that's going to reflect it over the X-axis. Do I do that first or last?
Last.
Not
First.
first.
I
If
know.
he's on the Y, he's first. If he's on the X, he's last.
You said, man.
Okay? So it's going to take this graph right here, okay? And he's going to take him and he's going to flip him down. And now he's going to look like this. Okay? So what's this -3 going to do to him?
No.
Moves to
Right
the
three.
Right 3. 1, 2, 3. What's this +1 going to do to him?
Up one.
Up 1. So this is his starting point. His slope is -2. It's not really a slope. How many times can I use it? One time. One time. You use it more than once and you're wrong. Okay? So I can go down 2 and to the right 1. And here is my graph of the pink. Now what did I just make?
A parabola.
Yeah, you made a sideways parabola. Right there. Here's the positive part of him and here's the negative part of him. Okay? One more. We're going to do a hard one. Here we go. Y is equal to the square root of -x plus 2 and then -3 out here.
Alright.
Okay. So this negative on this x, what is that going to do to it?
Flipping across the Y.
All right. When?
Last.
Last. Okay? So I'll start right here. What does this +2 do to it?
Left 2.
Left 2. 1, 2. What's the -3 do to it?
Down 3.
1, 2, 3. Okay? So his slope is 1. Do you agree? How many
Agree.
times can I use that? One time. So watch this. Look up here. I'm going to go up 1 and over 1. And then I'm going to say, well, if that negative wasn't there, do you agree that that's what my graph would look like?
Agree.
But because that negative is there, I need to reflect him over the y-axis. So instead of being 2 to the left, he's going to be what? 2 to the right. Okay? Instead of opening to the right, he is now going to open to the left. So I'm going to go up 1 and to the left 1. And this is what your graph is going to look like.
Oh my gosh, I don't like that.
Okay? Now look what you're looking at. If I folded this on this y-axis, would this point land on top of this point?
No. Yes.
Would these two
Yes,
points
yes,
land on
yes,
top
yes.
of each other?
Right.
That's a reflection. Would these 2 points land on top of each other?
Yep.
Would this part of this curve land on this part of the curve?
If you did it right.
And would this part of the curve that goes out here land on this part when you folded it? Okay, so this is what it looks like. Kind of weird, all right? Kind of weird. All right, so write this down. These are your homework problems. Page 127, page 127, 21 through 26.
I cannot believe we spent 35 minutes.
21 through 26. Well, that's okay, because you're fixing to be busy, and be glad you have the 35 minutes. All right, so what I'm gonna do is I'm gonna put those problems up here, okay? I suggest you take a picture of them, all right? And actually, what I wanna do is this,
Are we getting a worksheet?
okay? So, here the problems are, so snap a picture.
Park there,
All right, 21 through 26. How many points are on your graph? 3 points, okay? So I want to show you what I want your paper to look like.
My phone, like, it
Okay.
just can't take pictures.
This is what I want your paper to look like. This is what I want your paper to look like, okay? Here's the black points. What order do we put them in?
Least grace.
No.
Left to right.
Left to right. Left to right. Okay? Y'all listen to me. You put those out of order and you're gonna miss every stinking one on here. Okay? Left to right. That's the way you name your points. Alright? So this one will be first. On the test, I'm gonna give you a graph just like this, but I will not tell you what the points are. You'll have to figure them out yourself. You're just gonna list them left to right. Okay? And then like number 21, this is the function. Y is equal to f of x plus 2 minus 3. Thank you. And then here's where this point's gonna go, this point's gonna go here, this point's gonna go here. 22, write your equation. This point's gonna go here, this point's gonna go here, and this point's gonna go here. Does everybody understand what I want it to look like? Is this gonna be easy for me to grade? Yes. You're gonna put it on a piece of notebook paper, and then you're gonna staple your stuff together. The first page is gonna be the first number, it's gonna be 34 through whatever of the regression problems. The second page, the front of it's gonna be the second page of the regression problem. And the third page is gonna be this right here. Alright?
Perfect.
And I'm gonna grade it, it's due next class, and I'm gonna grade it and give it back to you. You can come and get it the next day. That way you can get to look at it, okay, before your test, which will be the next day.
Got it.
Alright, good deal. So,
May I take a picture?
yes, you can. Here's the book if you need a picture. I'm gonna turn the video off. You gonna turn it off?
I will.
Sneak. Okay, so since Cheer's leaving, like literally right after school, I was gonna ask if an advisor